Hello everyone and welcome to the 8th episode of my devlog series about the development of a simulation game called Leah. This week was quite a challenge. Even though I had a lot of time to work on my game, things did not seem to go well. But everything changed last minute. Continue watching to find out what happened. In this episode you will see the whole process of creation of a character for my game. This includes turning a 3D model into a 2D animation, character AI, and pathfinding on an isometric grid. Without further ado, let's get started. This week I decided that I want to add some life to my game. I didn't find any 2D characters that would meet my requirements for this game, so I remembered that sometimes games combine 3D models with 2D environment, so I decided to give it a shot, and it almost made me give up on my game. First of all, I found a tutorial on how to turn a 3D model into a pixel animation. In the comments to that video, I read that this technique can also be applied to make regular art. You just need to increase the size of a single sprite and enable smoothing. So, I went searching for my first character. I discovered this website where you can get various animations for 3D characters. It already provides a set of models, but you can also upload yours and apply animation to them. I'm sure this tool is a must-have for 3D game developers. By the way, if you want to see me try and make a 3D game for the first time, let me know in the comments. I wanted to do so for a long time now. After exporting your model to Unity, you may have a problem with textures, so I left a link to a video on how to fix it in the description box. In order for the tutorial to work for an isometric game setup, you have to rotate the capture camera to 30 degrees on the x-axis and 45 on the y-axis. And there you have it, a walking character in your game. To make the character to be able to move in all 4 directions, you have to capture each direction. Just rotate the model and repeat the steps. I added a simple controller for the character to change the current direction after pressing a space button. In fact, it is just a bunch of if statements, which play animations depending on the current direction of the character and the new direction. To make the transition smoother, I made turning animations. And you know what? Let's count how many animation sheets I had to make in order to animate one single character. Firstly, a walking animation. Then, 3 turning animations, to the left, to the right, and a full turn, in case the character needs to turn in the opposite direction. And not to forget the idle animation. Finally, if we multiply everything by 4, we have 20 animation sheets in total. Each of them I had to slice and turn into an animation. A little tip: if you have a lot of animation states, you should change them through code and not with the parameters. Otherwise, you might end up in animation hell. I followed a tutorial on how to avoid this. Link is in the description. The next thing I had to make was path for the character to walk. I thought about making a wooden path because I already had wooden tiles, but their size wasn't fitting to my grid size, and making 2 tiles in each grid cell wasn't working as well, so I switched to these rocky road tiles. I might do a customization option in my game, so you can upgrade towns' roads. As you can see, they look a lot better with the general environment of the game. Also, you should note how close the road comes to the building. This got me thinking how to achieve the same effect in the game, and not just in the tests where I used tile brush to manually place the road. This led me to my next step, the implementation of pathfinding. You may already know that I am all about making my dev life easier, so when I found a tutorial on how to implement pathfinding on a grid, I just copied and pasted the code into my game. I had to install 2D Extras package to get access to the rule tile. If you don't know what that is, it is a tile that has multiple sprites and a set of rules on how to connect them. It means that it automatically sets a different tile sprite, depending on the position of a tile, whether it is at the end of the road, or in the middle, or at a turn. The path was generating fine, although I had to do some modifications at the end, so that each time I place or move a building, the roads get updated. But at this point, I started making my character follow the path. The plan was to find a path with the same algorithm as I did for the road, except this time use a road as the available territory. My approach was good, but I couldn't get the player to turn. At first, I tried eliminating all the points from the path that were lined up. I thought it would make my life easier, but I ended up with weird character behavior. Sometimes it would skip a point completely. Sometimes the direction was wrong, or it wasn't turning at all. Next, I tried following the path point by point and detecting direction there. It was better, but I still got wrong turns. At this point, I was ready to give up. I tried putting a 3D model into the game as is. I've seen it done in other games. To create an isometric effect, you just rotate the camera. But my game was in 2D from the start, and converting it into 3D would cost me most of my progress. I tried rotating the character to make it look isometric, but it was impossible to achieve the same isometric look in all 4 directions. I thought that it was over and moved on to the next best thing, making portraits and character descriptions. It was the least I could do to make some progress this week. I made these pictures with a website for avatar making. Honestly, I'm not happy with the way they turned out. I tried making them less graphic, but I don't think that it worked. I also added flipping so it seems like you're flipping the portrait to read the description. This video could have been over now. I made almost no progress this week, but something happened. A turning point. It was 9 p.m. already. I was supposed to rest and get ready to sleep. But I got so inspired. I recently hit 100 subscribers, and I felt great because of that. So I decided to try to write the algorithm one more time. I used paper and a pencil, went through each step, each iteration, tried it in the game, and it worked! It still had a minor issue, but now I could clearly see how to correct it. I want to thank everyone who subscribed to my channel. It means so much to me that you're interested in my game. I see every comment, every like, and it makes me feel so happy. It motivates me every day to the point that I can even solve issues with my code. So don't forget to subscribe and like this video. The next morning I finished the algorithm. I also returned to the road generation, because when the road changed, a character might have gotten stuck in the middle of a field. I wanted to make it walk to the nearest point on the road, but it didn't work, so I did a little trick. Actually, now I have my own story when I turned a bug into a feature. I couldn't get the character to walk to the new road, so I made an effect like it was teleporting to the new spot. This is a magic town after all. After all hard work that I've done over the past week, I can now say that it is time for the finale. This is how the game looks now. The roads in town are automatically generated between all the buildings. The character successfully walks on the path and makes smooth turns. After a walk, it stops and idles for a few seconds, then continues walking somewhere. If the roads were changed while the character is walking, it would continue its path, but after the stop, it teleports to the closest road and continues its cycle. And this is it for this video. Thank you for watching. Don't forget to like this video and subscribe to my channel to see weekly updates on this game. Bye!